and welcome back to Cap That Flag. Today we're continuing our picoCTF series with a challenge titled Easy Peasy. It's worth 40 points, it's from picoCTF 2021, and it's in the cryptography category. The description reads, a one-time pad is unbreakable, but can you manage to recover the flag? And we're given a netcat command to connect to a picoCTF server and a link to a Python script. So let's start by using the netcat command to connect to the picoCTF server. And it starts out by giving us a ciphertext of the flag and then asks us what data we'd like to encrypt. So if we give that a character, it'll return some more ciphertext, and we can do some experimentation to get some clues about how this works. So if we try the same plain text again, we're getting a different ciphertext every time. And it looks like every character of plain text becomes 2 characters of ciphertext. And I'm going to see how many characters are in the ciphertext. So 64 characters in the ciphertext for the flag. So that means that the flag must be 32 characters long. So just quickly looking at what a one-time pad is, just on the Wikipedia page, and it refers to one-time pad as an encryption technique that cannot be cracked, but requires the use of a single-use pre-shared key that is larger than or equal to the size of the message being sent. You've got each bit or character of the plain text is encrypted by combining it with the corresponding bit or character of the pad. And further down, we've got an example here. So Alice wants to send hello to Bob. So hello gets converted into numbers, and then the key provides these characters here. And then in this implementation, they're adding up the 2 numbers to get these numbers here, and then performing a mod 26 on those numbers, which then turns into these numbers here, which turn into these letters here, which is the ciphertext. And then down the bottom, they just do the reverse to get the plain text message out again. And one other thing to note is that the ciphertext will be impossible to decrypt or break if the following 4 conditions are met. So the key must be at least as long as the plain text, the key must be random, the key must never be reused in whole or in part, and the key must be kept completely secret. So taking a look at the Python code now, we have a key file and a flag file specified, and a key length of 50,000. We have 2 functions, a startup function and an encrypt function. And first the startup function will be called, and then encrypt will be called multiple times in a loop. And within the startup function, we first open the flag file, and then we open the key file, and we're using these start and stop variables as a way to select a part of that key file to use as the key for this particular function. And then this line here is doing the encryption. And the main part to look at is this bit here, where we're essentially doing an XOR on the flag and the key. So unlike the example in Wikipedia where it was adding the 2 together, in this instance we're doing an XOR or exclusive OR on the 2 characters. So taking a look at this encrypt function now, it's very similar to the previous function. The main difference is instead of loading the flag file and encrypting that, it's actually asking for user input and then encrypting the user input. But the method's the same. The encryption code here is exactly the same. You're still doing an exclusive OR between each character of the flag with the corresponding character in the key. There's also some extra code in this section that deals with the scenario of running out of key space. So if we get to the end of that 50,000 characters, the implementation they've chosen is to then loop back to the start of those 50,000 characters and start reusing them. And by doing it this way, they're actually introducing a vulnerability into their implementation, and we should be able to exploit that to decrypt the flag. So as we touched on before, for the one-time pad to be unbreakable, the key must never be reused. And in this case, we can trigger a scenario where the same key will be reused. So I just want to run through the logic of how we can get the plain text flag. And this relies on us being able to force the same key to be used that was used to encrypt the flag. But if we just look at the first byte of the encrypted flag, and it's a 51, and we know that that 51 was generated by a key byte being exclusively ORed with a flag byte. So this is the plain text flag character here. And if we work out either of these unknowns, we can then use them with the encrypted byte, perform an exclusive OR to calculate the other unknown value. So if we have the plain text flag and the encrypted flag, we can calculate the key. Or if we have the key and the encrypted flag, we can calculate the plain text flag. So what we're going to do is we're going to find out what the key value is by providing a known plain text flag value. So if we tell the program to encrypt the character capital U, which has a hex value of 55, and we get then the output of hex 37, we can then perform an exclusive OR on both of these, and we'll then get the key value, which for our example would be an output of 62 or a lowercase b. We would then know that this value here is 62, and if we ran an exclusive OR of 51 and 62, down here, we would then be calculating the flag byte, which would be 33 or the character 3. So by this process, we've then determined that the first character in the flag is a 3. And we could repeat that for every other character in the flag. So there should be 32 characters in the flag, and we'd be able to get the entire flag that way. So I've created this Python script to do all the tasks that we need to do to decrypt the flag. I'll just talk through it quickly. So it's using the pwntools Python module. We haven't needed to use this before in any of the CTF videos, so I'd recommend having a look at the documentation and getting a hang of how it all works. But essentially it's a Python library that's quite useful for exploit development and capture the flag challenges. So we're starting out by connecting to the picoCTF server, and we're receiving until we get the line, this is the encrypted flag, and then we're storing the encrypted flag to use later. Then after it asks us what data we'd like to encrypt, this is the way we're going to force a reuse of the key. So I'm sending 49,968 capital U's in a string, and I get that number by subtracting 32 from 50,000, and that should loop all the way through the key back to the start, so we then reuse the key. Next, I'm asking it to encrypt 32 capital U's in a string, and this should be using the exact same key as was used to generate the flag ciphertext. So then we also store the ciphertext for the 32 capital U's. So then I create a list out of that string, and then we loop through that list. And for every element in the list, I'm performing an exclusive OR with the number 85, which is the ASCII for a capital U, and converting that to a character and adding that to this key variable. So after this loop's completed, we then have all the characters that make up the key stored in this key variable. And at this point, we've now calculated what this unknown key byte actually is for the entire length of the key. I'm then converting that key string into a list, and the encrypted flag is also getting converted into a list. And then I'm simultaneously looping through the key list and flag list together and performing an exclusive OR between them and building up the final flag and then printing out the flag. So if I run that now, so it's showing us the flag ciphertext, and we've exploited the program to get back to use the same keys was used for the flag, and then we're running our 32 capital U's through it, and we're getting this ciphertext. We're performing the exclusive OR between the 32 U's with the ciphertext to get the key, which is this string here. We're generating the two lists and then XORing them together to get the output, which should be the flag in plain text. So here is the flag in plain text. So that wraps things up for this video. Thank you so much for watching, and I'll catch you in the next one.